Hello, good morning everyone. Welcome to my presentation on the multi-table joins through bitmap join indices in database. This is Premkumar Malepati presenting this presentation. So I will be starting my presentation with the introduction, overview of the multi-table joins, following by the problem statement, significance, challenges, and I'll be ending my presentation with advantages of the bitmap join indices and methodology in databases, impacts, and with the conclusion. The efficient processing of database queries is a crucial factor for achieving optimal performance in relational databases. The access path selection problem, in this regard, it involves selecting the most efficient way to access data in a database for a given queries. In this presentation, we will discuss in detail about the access path selection problem, its importance in the context of relational bases, and the proposed solution to optimize query execution. So let's deeply delve into the details and explore this topic further. Bitmapped join indices are a type of index structure used in relational databases to optimize query performance. The structure of these indices and their use of bit vectors for efficient join processing. They are based on the idea of using bit vectors, which are arrays of bits that represent the presence or absence of a particular value in a set of records. A bitmap join index consists of a set of bit vectors, each of which corresponds to a distinct value in the indexed columns. For example, if the index is created on a column that contains values A, B, and C, there will be 3 bit vectors, one for each of these values. The bit vectors are used to quickly determine which records a given query condition without having to scan the entire table. This is the significant point and significant method used in these indices. When a query is executed, the bit vectors corresponding to the values in the query condition are logically ended together to produce a final bit vector that identifies the matching records. Bitmap join indices are particularly useful for optimizing join operations between large tables, as they allow for very efficient processing of join conditions. There is a very efficient structure of these bitmap join indices. This structure is designed to be very compact, efficient, so they can be created and maintained with relatively low overhead. The problem statement in the paper is related to access path selection problem, which refers to selecting the optimal strategy to execute a query in a relational databases. Specifically, the paper addresses the challenge of performing multi-table joins efficiently. Join operations involve combining rows from multiple tables based on a specific condition, and this can be also based on the primary key and the foreign key, and they can be time consuming and resource intensive if not executed optimally. This is completely depends on the keys present in the table. The paper proposes a solution to this problem by introducing bitmapped join indices, which help or utilize bit vectors to efficiently process joins. By selecting the best access paths for query execution, the proposed solution aims to minimize query execution time and improve overall database performance, which would really be helpful in this case. Efficient join processing is a crucial factor for the performance of relational databases, as joins are commonly used to retrieve information from multiple tables. This is the very significance of this problem. To join processing in real-world applications, it makes more complex. In real-world applications such as e-commerce or banking systems, efficient join processing is essential to provide timely and accurate results to users. The significance of the problem addressed in the paper lies in the fact that join performance directly impacts the overall database performance and user experience, which will make user to delve into deep problems. The use of join indices, particularly bitmap join indices, can provide significant performance improvements for a wide class of queries, making them an important area of research for database optimization. In modern database systems, the use of bitmapped join indices has become increasingly popular due to their ability to provide faster and more efficient join processing, which they can also provide significant performance improving over traditional join processing techniques. These indices can significantly reduce query execution time, improving database performance, and enhancing the user experience. Moreover, advancements in hardware and software technologies have enabled the use of more sophisticated indexing techniques such as bitmap compressing and partitioning. These techniques can further optimize the performance of these indices, making them even more attractive for use in large-scale databases. And this helps in compressing bitmap and partitioning. Overall, the use of bitmap join indices is a valuable tool for optimizing query execution and improving database performance in modern data-driven applications. There are a lot of challenges including in this bitmap indices. The main challenges is addressing the problem efficiently performing multiple table joins. This is related to computational complexity of large tables and which are having multi-table joins. While dealing with the multi-table joins, they would be required the large search space, which would really be crucial and makes user more complex. The existing join algorithms require excessive input and CPU time. This would really make some complexity. Another challenge is the selection of best access path for query execution, as this can have a significant impact on database performance. Additionally, optimizing join processing requires a deep understanding of the query workload and data distribution, which can be very difficult to obtain in real-world scenarios. Finally, as the size of databases continues to grow, the scalability becomes a significant challenge, as traditional join algorithms can become prohibitively slow on large data sets. This is the crucial challenge while dealing with the bitmap indices with large data and multi-tables. And my work had some limitations to the prior work. In this, existing join processing techniques such as nested loop join and sort merge join and their limitations be having some impact on the table. These techniques can be inefficient in terms of performance and resource usage. Let's deeply delve into each join. Nested loop join. This technique is suitable for small tables or when joining only a few records. However, it can become extremely slow for large tables as it has a time complexity of sort merge join. This technique sorts both input tables by the join key and then performs a merge operation. While it has a better time complexity, it can still be slow and resource intensive for large tables. There is still some crucial impact while dealing with the large tables for the sort merge join. And finally, hash join. This technique involves partitioning the input tables based on the join key and then performing a hash-based lookup to identify matching records. It can be faster than nested loop and sort merge joins, but it requires an important amount of memory for the hash table. It is important to note that while these techniques have limitations, they are still commonly used in many database systems due to their simplicity and easy to use of implementation. Also, some traditional join techniques can lead to excessive input output and CPU time. This would also be a crucial point. A comparison chart of existing join processing techniques helps in this kind of issues. I found some novelty based approach which leads to introduction of bitmap join indices as a new approach to multi-tuple join processing. Additionally, bitmap join indices have several advantages over traditional join processing techniques. One key advantage is that they can be created and maintained more efficiently as they utilize bit vectors instead of full table scans. This helps in reducing the complexity of join processing and enables faster query execution. This would also be considered and done by advancing of bitmap join indices over existing techniques. These join indices can more frequently used to process multi-table joins more efficiently, which leads to the large data. There were multiple advantages of dealing with bitmap join indices, such as reduced input-output time and computational cost. Another advantage of these indices is their ability to handle complex queries with multiple conditions. By using bit vectors to represent data subsets that satisfy specific conditions, bitmap join indices can effectively reduce the search space and avoid unnecessary data scanning. This results in improved query performance and reduced resource usage. Furthermore, bitmap join indices can be compressed and partitioned to further improve performance and scalability. Compressed bit vectors use less memory and enables partitioning, parallel processing of data subsets. These features make bitmap join indices a powerful tool for modern database systems. Last but not least, bitmap join indices have advantage over traditional indexing techniques such as B-tree indexing in terms of query processing speed for certain type of queries. These indices can provide fast and efficient processing for queries involving multiple tables, as we discussed before, especially in cases where the tables have large number of rows and relatively few distinct values. This is a very rare case and happens mostly in the IT field. This approach can also be highly efficient for queries that involve complex conditions or aggregate functions. Overall, the use of bitmap join indices can lead to improved database performance, which helps in reducing time of execution and helps in better user experience. There were several contributions which helps in this new approach to multi-table join processing and also the new advantages with new techniques. The paper also proposes a method to efficiently maintain a bitmap indices during updates to the database, which is a very significant contribution to the field. The authors demonstrate the effectiveness of their approach through a set of experiments on real-world datasets, providing empirical evidence of the performance improvements that can be achieved using bitmap join indices. Overall, the contributions of the paper provide a significant step forward in the field of efficient multi-table join processing. And joining these indices can dramatically reduce the time required to perform operations. There were several methodologies included in this paper. The methodology used in this paper includes an analytical evaluation of the proposed bitmap join indices approach along with a comparison of its performance with existing join processing techniques. The authors used a benchmark dataset and evaluated the performance of different join algorithms on it, including nested loop join, sort my join, and hash join. The strengths of the validation methodology include the use of a benchmark dataset, which provides a standardized way to compare the performance of different set of algorithms. And they also performed a detailed analysis of several join algorithms, which allows for a fair comparison between different techniques. However, one weakness of the methodology is that the benchmark dataset may not accurately represent real-world scenarios, which might be a complex problem and also can affect the generalizability of the results. Additionally, they did not consider the effects of different hardware configurations or the scalability of the proposed approach. There were several impacts related to this indices topic. The join index has been implemented in a commercial database system. Additionally, the use of bitmapped join indices has had a significant impact on query optimization techniques, and this led to development of new indexing methods. The bitmapped join index has also paved the way for other related research in the area of efficient query processing, such as bitmapped aggregation and bitmapped clustering. Overall, the adoption of bitmapped join indices in modern database systems has contributed to improved query performance and faster data retrieval times. To conclude, the success of bitmapped join indices in improving query performance has opened up new possibilities for complex query processing in modern database systems, which will really be helpful for dealing with the real-world data scenarios. These bitmapped join indices have been shown to be effective in a variety of query scenarios, making them a valuable addition to the database optimization toolkit. The paper's detailed analysis and validation methodology have helped establish the reliability and effectiveness of the bitmapped join index approach. The adoption of bitmapped join indices in commercial database system underscores their practical significance and impact on real-world applications. To conclude with the topic, the paper's contribution to the field of query optimization and multi-table processing highlight the importance of exploring innovative approaches to database performance optimization. It also deals with the checkmark symbolizing the success and innovation of bitmapped join indices. These are all the references I consulted and used for this topic. Thank you so much everyone for paying attention to my presentation. Thank you all.